Hey guys, welcome to this introductory video on product and some principles. So, what is the product principle? Well, let's think for a moment. If we've got this bit of a network here from P to Q to R, we want to travel from P through to R. How many different ways are there of doing it? Well, we could count them out. We could go from P to R along the top, P to Q along the top, then Q to R along the top, again along the top there, along the top from P to Q, from Q to R straight, so that's two ways, P to Q, and then along the bottom from Q to R, that's three ways, and then we could double it because we've got this other way from P to Q along the bottom. But what happens when we start to get more and more complex systems, where we start looking at networks and the way to get from one point to another? Well, that's where the product principle comes into it. So we've gone through and we've counted the ways here, and we can see that there's two ways to go from P to Q. There's two ways. There's also from Q to R, there's three ways. How many ways in total? Well, what the product principle will tell us is that if there are M number of different ways to performing an operation, so let's just say from P to Q is an operation, and we'll call this M. And for each of these, there are n different ways of performing a second independent operation. So we'll go Q to R as being our second operation, as n. Then there are m times n different ways of performing the two operations one after another. So how does this look if we've got something? Let's draw up another one where we go from A to B, and then we're going to go to C. And let's go for another one of D. So let's make it two ways here. That's not the best drawing, but anyway. One way here, let's add on three ways, and from C to D, let's make five different ways. How many ways in total is there from A to D? Well, let's look at it. We've got two ways from A to B. There's two ways. B to C, three. And from C to D, there's five. Well, what the product principle will tell us is if we just multiply these three numbers, so the 2, the 3, and the 5, all together, then we'll get number of ways in total that we can get there. So, how many different ways are there? Well, 2 times 3 times 5. 2 times 3 times 5. What does this equal? Well, 2 times 3 is 6 times 5. There's 30 different ways. From A to D. So, where can this be used in real life? Well, if we think about combination locks, where you've got like an old bicycle chain lock where you might have 6 different numbers, and you've got to get those 6 numbers or those 10 numbers lined up. So you might have 1 through or 0 through to 9 on one tumbler, 0 through 9 on another tumbler. how many different combinations are there in total? And that's where this will come into its own, and we can actually work it out mathematically. So what about the sum principle? The sum principle. If we've got a more of a road system where we might have a point P and we're going to join it to point A, B, C, and then eventually Q will be our final destination. But along the bottom here we've also got D, E, and F. So let's draw in some of these. We're going to have one way between P and A and D, two ways between A and B, three between B and C, and one between C and Q. Between D and E we're going to have four different ways. Between E and F we're going to have two different ways, and again one way between F and Q. So you might start to think, well, this kind of looks like a bit of a roadmap and how we could get from P to Q. And the application of this, as I mentioned before, like networking. So if we're looking at computer networks, trying to get from information from one side of the world to the other, we can actually use this, or the basis of this, to work out what's the best way to send data, or how many different ways are there to send data around the world. Well, let's look at it. Let's take the path P, A, B, C, Q. Let's look at this. How many different ways are there? Well, we've got 1 times 2 times 3 times 1. So all of this is just 6 different ways. What about from P going through D? So let's write it out. P, D, E, F, and Q. Well, there's 1 times 4 times 2 times 1. And that would give us 8. So this is where the sum principle comes into it. How many ways in total is there to get from P to Q? Well, we've analysed and looked at going along the top line, and we've looked at also the bottom line. Well, the sum principle, like as its name suggests, is really just we add the two together. So in total, to go from P to Q, there's going to be 6 plus 8 different ways, which is equal to 14 different ways. And that, in a nutshell, is the sum and product principles, or product and sum principles. So if you've got any questions about it, just ask, and hopefully I can answer some of them. If hopefully you've enjoyed the video, if you've got any comments or suggestions, please let me know. I'm always looking to improve these. Hopefully you've gotten a bit out of it. We'll see you in class where we'll get on and do some questions. Thank you for watching.